structure here. What's this? This, what? The cornea. What do you know about corneas? Corneas are bizarre. Can we transplant corneas?
Yeah.
What is the unique thing about transplanting corneas?
They don't have blood vessels.
They don't have blood vessels, therefore, what don't we have to do?
Match them.
You can just transplant corneas. There's no there's virtually no rejection in corneal transplants. So kind of wild. And here we have your pupils, the colored part of your eye. It comes in lots of different colors. One of these semesters, I am going to sit down with all my students, get all the eye colors, and to see what the distribution is in the class. I think it'd be wild. And here are the pupillary constrictor muscles sitting in the center here. So as when they relax, you are dilated. When they constrict, they close down, and your pupil closes. So I think we've talked about that a little bit sometime in the past. And then we have your lens. Lenses are interesting structures. Once again, they're proteinaceous. The lens sits in a membrane that is attached to the suspensory ligaments, which attach to the ciliary muscle. Now, so the lens is in the middle, and the lens can flatten, or the lens can bulge. Ciliary muscle relaxed. What's the shape of the lens? Flattened or bulged?
Flat.
Ciliary muscle contracted. What's the shape? It's bulged. Explain it.
Can I grab around on the opposite side? Pull the opposite side.
Not really. What it looks like here when it's relaxed is that everything is at the ends, right? I mean, that's what it kind of looks like. The reality is, let's do a bulged one. Is that these don't attach to just the center. They are attaching about, a third of the way across to that membrane that surrounds the lens. So that as they constrict, so as the muscle contracts, it's doing this. It contracts and it pulls like this. When it relaxes, it does this. Because if you were to just take something like that and pull on it, it would get thinner. It would not bulge. The other thing you have to remember is that these muscles go all the way around the eye. They're not just at the sides. So while this is happening on the sides, it's happening up here. It's happening over here. Happening over there. So it's happening everywhere. And it's pulling not just on the edges, but on a wider piece. So when it pulls, it does this. Relax, contract. Relax, contract.
So it's pulling more on the outer edges as opposed to the center. So
Well, it would be really nice if there was some sort of model for this. I've never seen a model. So from the side here, these are coming out, holding here, all through here, and pulling. Those are holding out there and pulling. If we rotated this so that it was like that, at the bottom, it would be coming up and it would be kind of on the front here a little bit and on the back a little bit. So you have to try to envision this rotating. It's really hard to do. But if you can visualize and attempt to understand that, then this makes really good sense. Now, those signals coming in.
I have a question about that.
Yeah,
Is that what causes stigmatisms of your eye?
astigmatism of the eye comes about by a misshape of the eyeball.
Okay.
Astigmatism.
It's not the muscles
No.
necessarily.
No, it's the shape of the eyeball.
Okay.
So when you have an astigmatism, at least I think this is what it is. When you have an astigmatism, the eyeball is out of round.
Okay.
So the way they typically they can deal with that surgically is to go in, do some laser cuts, and turn your eyeball into a sphere. So, because you can have astigmatism corrected with laser surgery. You go in, you get old, like some of us, you need to have cataract surgery. Now maybe you've known somebody with cataract surgery. What they do is, they go in here, they make an incision in the membrane of the lens. They literally take a laser or something and pop up the lens, suck it out, and put a lens made out of eyeglass material in. So, kind of wild. Doesn't take long. It's like a 20-minute surgery. What is disturbing though is when you wake up during surgery. He did that. And I got to watch the last 5 minutes of my eye surgery from the inside, which was totally bizarre. All right, your eyeballs are working now. You're collecting light data. It's coming back. I want you to pay attention to the ciliary ganglion, Edinger-Westphal, the lateral geniculate, and the pretectal nucleus. I'm going to blow it up. There we go. So light hits the eyeball, signal comes in, some of it crosses over, some of it is ipsilateral, okay? Comes back to the pretectal nuclei, where the signals are then bilateral to Edinger-Westphal. So the signal from this one goes there and there, signal from this one there and there. Signals from Edinger-Westphal, bilateral, coming out the two different sympathetic oculomotor pathways. That's kind of cool and straightforward. All right, that's about what I want you to know about eyeballs and eyes. So you have we've got the muscles, the actions, and the innervation. Can use that. We've got the various nuclei. You should know the nuclear arrangements in the midbrain here, in the upper midbrain. You should know the nuclei, the muscles that are innervated, and the mode of innervation. Then the structure of the eye. We have pupillary constriction, pupillary relaxation. We have ciliary contraction and relaxation. So, and the pathways, of course. Believe it or not, we covered a bunch of stuff. Okay, you've got the visual pathways, you've got the auditory pathways, and you've got the vestibular pathways. So there are a bunch of pathways. All the other cranial nerves are actually close to simple. You get past vision, audition, and balance. Those are the real complexities. All right, would you like those exams back to look at? Grades are posted. You saw grades? No? Oh, they're posted. Oh, sorry.